So we just want to wish everyone a very good evening again for the new normals presentation tonight in our webinar. So I'm Joe Deli Carpini, the Science and Operations Officer. Figured it was time for a new picture there too. So there's my office picture. With me tonight is Rodney Chai, one of our meteorologists and a member of our climate team, and Bill Leatham, who's a meteorologist and the leader of our climate team. So these two are going to tell you all about the new normals and talk a little bit about how they're different, things like that, and also get into a little bit of climate change too. So with that, I'm going to hand it over to Bill to get us started. Go ahead, Bill.
All right, good evening, everybody. So this is just a little overview of what we're going to talk about tonight. Joe already kind of alluded to it, but we first probably should go over what a climate normal is, and the question we kind of get asked is why are they 30-year averages? And then those next two bullet points, the new normals, the 1991 to 2020 normal, and then comparing the previous normal, which is the 1981 to 2010, to the new normals. Those are all going to be kind of combined into, and you'll see it a little later, combined together. And then, another question we get asked is how does this relate to climate change? And we'll touch base on all those kind of things. So just a real quick little history on how the normals were defined. It's an average over a recent 30-year period, and this happened by the World Meteorological Organization, and other member nations are instructed to calculate the normals using 30-year periods. And of course, the United States, we're a member of the World Meteorological Organization. The first normals that were calculated were from 1901 to 1930. And that was mainly because they, finally had a good period of record of data and a decent enough network of data to kind of get a representative normal. But when you go into mathematics, and a general statistics kind of rule is you need at least 30 numbers to get a reliable estimate of the average, or another way to say it is also the mean. But really what it ultimately boils down to with why we do 30-year normals is it's the accepted convention. That's not to say that if you calculate it different ways that's incorrect, but it's just how we've always done it, and just to stay consistent as we go through time. So, when you're looking at climate normal, what does it tell you? So really, it's a reference period for monitoring the current weather and climate. And basically, it's kind of characterizing today's climate in context of what's going on now, rather than tracking or defining the long-term trends or changes to the climate. Although we will talk a little bit more about, what stuff you can glean from it about climate change, but we'll talk about that a little later in the presentation. Now, the climate normals are important for a couple different things. It's really important to the energy sector for load forecasting based on the demand for energy. So, when these last couple of days it's been really hot, you have to have a certain amount of energy output for folks cooling or heating their homes. Obviously, in this case, this week we've been mostly cooling our homes. So you need to have, the climate normals are kind of help with, how much money is going to be spent when you're stressing the system. Another reason that it's important is that's for crop selection and planting times, construction and building design. As you have, changing climate or different, as the normals change, you're going to have different crops and different plants that are going to work well in particular regions. But ultimately, that really, for most folks, when you're looking at it, it really boils down to putting the current weather and climate into it's kind of a historical context, into what the current climate system of the climate is in relation to what weather's been happening. That's mostly what we refer to it as. Is when we're looking at it like our highs and lows of the day, we're comparing it to what's happened over the last 30 years. And then a few more things, and again, sorry for all the text here, but just a couple things to cover before we get into some images. It's not a simple 30-year average. You can't just take the last 30 years and and average it out, and there's your normal. The reason that is because some locations don't actually have complete observations. We have systems that go down. It's anything that's like a car. Sometimes they need maintenance, and that means that there's downtime. So how do you get how do you get a 30-year average or a 30-year normal when you have this missing data? Well, there's some complex estimation and scaling stuff that they do to ensure that stations represent a full 30-year period, and then also that the data is internally consistent. I don't have more on this. If folks want to, look more into how they exactly calculate the normals, there's papers out there that go into it, but it's kind of deep for this kind of presentation. So the other question is, are there other normal periods? Well, in this latest update, the NOAA, the National Centers for Environmental Information, or also known as NCEI, they're providing a complete set of 15-year normals that cover 2006 to 2020 for a specialized user group. I don't believe those are out yet, but that's something that if folks wanted to look at like a shorter normal period, you could look at it. But when it comes to anything our office puts out or any of the National Weather Service offices put out, we're still using that. We always still use those 30-year normal periods to reference any of our climate products. So if you're like talking the daily climate, the monthly, or the seasonal, we're talking about the 30-year normal and not that 15-year normal. That's for a completely different something else in the background. So let's take a look at the differences between the 1981 and 2010, which I call the old, and then the 1991 to 2020 are the new normals. But before I get into the images on the left, just a quick few other things before we go forward in the presentation. So when we're talking the average or the mean temperature, it is the average between the high and low temperatures. So anytime you see these images that have average mean temperature, it's an average of the high and low temperatures, and then that would be over the entire year, being annual. So when we're talking meteorological seasons, that's how we always reference when we're doing the seasonal products. So for spring, it's March, April, and May. For summer, it's June, July, and August. For fall, it's September, October, and November. And then for winter is December, January, and February. Now, looking at these images here, and you'll see in the slides coming up that we zoom in and really hone in on southern New England, so you can kind of get a better idea of looking at what things look like in our area. But looking at the country as a whole, or at least the lower 48, warming trends have continued when comparing the old normal or the new normal to the previous one. Warming trends have continued across the whole U.S., including southern New England. The only exception is, and you can kind of see across the northern plains and the Dakotas, and in Montana, and even a little bit in Iowa, where there's a slight cooling trend. And then for precipitation, it's really more variable, as you can see in like the southwestern U.S. and western U.S. It's been getting drier when comparing the previous normal to the new normal. And then, really for like the eastern half of the country, most places have gotten wetter in comparison to the previous normal. All right, so decided to make things a little nicer for folks and try to. This is the same graphic that we were just looking at on the lower 48 scale, but zoomed in into southern New England. And in all these graphics coming up on the next couple slides, the way it works is in the top, on the left-hand side are the differences. The top one is going to be the differences in precipitation from the previous, from the new normal to the previous normal, and then for temperatures in the bottom left. And then on the right-hand side, the precipitation normal for the 1991 to 2020 period is in the top right. And in the bottom, there's a little loop showing the annual normal, or the normal temperature, average temperature between 1991 in 2020 and 1981 and 2010, and you'll see the loop going through. And that'll be all the images you'll look at the same time. When it comes to precipitation, there's no loop, and that's mainly because there's just not, as you'll see a little later, there's been some increases and decreases, but it's not a lot. But so looking at these images, the differences that come up is that there's slight increases in precipitation across Massachusetts and Rhode Island. And then there has been a decrease across Connecticut. And then again, this is the yearly difference. When it comes to temperatures, there's been a half degree to 0.8 of a degree increase in temperatures, and you can see that the warmest is in north central Massachusetts. And then another way to kind of look at it too is looking at that loop of the images. You can kind of see that the warmer temperatures are spreading further north, and you'll kind of see that on the next couple slides as well. But when it comes to the 1991 to 2020 normals across southern New England, we generally have 45 to 50 plus inches of precipitation across the region. The average temperature over the years from 40 to 55 degrees Fahrenheit. The max temperature is 50 to 65, and the min temperature is 30 to 45. The one thing I do want to point out here, and I know we'll get asked questions about it, or we've gotten asked questions about it. There's no maps like this for the snowfall normals. It's only temperatures, and average temperatures, and precipitation. All right, so jumping to spring, March, April, and May. As you can see in the top left, there's really been a little bit of a decrease in precipitation, but it's really generally only across the interior. The color scale goes from 0 to 8 inches, and they jump up every 2 inches. So it's really falling within, maybe a half inch of precipitation difference in the comparing the new normal to the previous. But when it comes to temperature, and you'll see this trend on a couple or all the slides, there's been an increase in temperatures, but in this season, it's run generally from 0.2 of a degree to 0.4 of a degree Fahrenheit. And then when it comes to the 1991-2020 normals, there's generally 10 to 15 inches of precipitation. And then the average temperature is from 40 to 50 degrees Fahrenheit. But you can again kind of see it's not as it doesn't show up as strong as it did in the annual, but you can see that those warmer temperatures are pushing further north under those color scales. So when it comes to summer, again, there's really slight increases in this one in precipitation across the interior, but when you go to the south coast, there's slight decreases in precipitation. Again, because of the color scale, it doesn't really show up super well, but it looks like it's around a half inch of a difference across the interior, and then roughly a half inch when you're looking at the south coast. As for temperatures, there's been 0.4 to 0.8 of a degree Fahrenheit increase in temperatures. Again, you can really see, north central Massachusetts and even towards the Boston metro area really standing out on the graphic. When it comes to precipitation, the summer, the normal precipitation is 10 to 15 inches. And then with the average temperature, it's 60 to 75 degrees Fahrenheit with the new normal. But again, you could see when the loop goes through again, you could see that warming, especially across the Connecticut and even in the Merrimack Valley, where you can really see that there's been a jump up at least to the next warmer colors. And then, so for the fall, which September, October, and November, there's been slight increases in precipitation across southeast Massachusetts, where you have that half inch of precipitation contour in there. And you can kind of see that there's maybe been a slight increase elsewhere, but really not much. If it is, it's less. It's less than a half inch of new precipitation. But for temperatures, again, we could see the warming trend in temperatures anywhere from a half degree Fahrenheit to 0.8 of a degree Fahrenheit increase. And again, north central Mass and the Boston metro area really kind of show up. Although you can even see parts of the south coast showing up pretty well on that image. And then when it comes to the new normals, again, another season where we have 10 to 15 inches of precipitation across the region, and then the average temperature is from 45 to 60 degrees Fahrenheit. But again, you can kind of see when you're looking at the loop that those warmer temperatures are pushing the colder temperatures further north, showing that there's been a warming trend. And then I think with this, I believe I'm passing it on to Rodney, which I mean I've got it because this is his favorite season. So
Well, thank you so much, Bill. And I have to give a shout out to Bill as well because he created all these graphics using programming language. So thank you so much for producing the graphics. So taking a look at winter, so that's December, January, and February. So in terms of differences between the new normals and the old normals, there have been slight increases in precipitation across much of southern New England. You can see that's, again, that's kind of the light blue shading that indicates a slight increase. And then as for temperatures, in the bottom left corner, you can see a white swath of bright colors that indicates overall increase in average temperature. And so yeah, so overall the winters have been kind of wetter, if not snowier, but also warmer. And we can and later on in the discussion we can talk about the reasons why this may be the case. And so what about our southern New England climate sites? Just as a reminder, our 4 climate sites are Boston, Hartford, Connecticut, Worcester, and Providence, Rhode Island. And this graphics may be a little bit overwhelming, but generally the red colors indicate an increase and the blue colors indicate a decrease. So the first 3 columns are your average temperature, maximum temperature, and minimum temperature. So you can see, generally there has been an increase in average temperatures for our climate sites. As for precipitation, the pattern is a little bit messier. Some months it's an increase, some months have been a decrease. And as for snowfall, interestingly enough, the snowfall actually increased overall for our 4 climate sites, and especially in the winter months, December, January, and February, and actually even March as well, for at least some of the climate sites, actually for all the climate sites. So you can say maybe part of the reason why there's an overall increase in average snowfall is because of an increase in snowfall in March. So and all kinds of theories we can talk about, like why there's an increase in snowfall in March, but we'll save that for the discussion. So let's address the elephant in the room. Is this climate change? It's I would say in short, it's a complicated answer, but the short answer is yes. The longer answer is it's maybe not as straightforward as some people may think. So taking a look at the graphic on the top, that's the U.S. annual temperature compared to 20th century average. So starting from the top left corner, you have 1901 to 1930. And then as we progress to the right-hand side, that's an increase in 10 years. So as Bill mentioned, 30 years is kind of like an acceptable scientific sample if we want to get reliable data. So that's why we group the years into 30-year periods. And then every 10 years, we progress to the next 3 decades. And then eventually we got to the 1991 to 2020 on the bottom right corner. So you can see, so overall what you're seeing is that the blue shading represents colder than average temperature, and the red represent warmer than average temperature. And the darker the shading, the higher the intensity. So in this case, and probably unsurprisingly, the latest climate normal indicates, just really much above normal temperatures. Actually, especially for much of the West, and also closer to us in the Northeast. And as for precipitation, if you look at the bottom image, overall, through in recent decades, there has been a tendency towards wetter than normal conditions, especially east of the Mississippi River, and you can really see that with the latest climate normal, just that large swath of green. And remember, the darker the shading, the greater the intensity. So, in recent years, there have been a tendency for much higher than normal precipitation. And the precipitation really depends on the location. For us here in southern New England, really more so for the eastern 2/3. So, Joe, if you click forward, I think we have a series of images that Bill made. Just, going through the loop, that's 1971 to 2000, and 1981 to 2010, and then finally 1991 to 2020. You can see just basically that last image that we showed, much higher than normal temperatures across all of southern New England, and higher than normal precipitation for the eastern 2/3 of southern New England. Okay, so once again, that's the 1991 to 2020 image. So another way to look at how climate change may have affected the climate regime is to look at the climate classification changes. And this is hot off the press from, and this map is created by this climatologist in Alaska. His name is Brian. You can see at the bottom of the image, and what this shows you is the red. Let's focus on here in the Northeast. So notice the red icons. That's basically a change from continental warm summer climate regime to continental hot summer climate regime. Now, without going into detail with all the different climate regimes, there are plenty of them, and we can talk enough for an hour about the different climate regimes. But the key takeaway here is that, when you see the change from warm summer to hot summer, and so warm summer would be basically defined as like the cutoff point is 72 degrees Fahrenheit. So basically, there's been a tendency towards warmer temperatures, especially warmer summers, and we're going to talk in a bit about how we have been experiencing higher frequency of heat waves and also longer duration heat waves here in southern New England, especially in the past few decades. And like I said earlier, we have been experiencing more frequent and longer heat wave seasons. And if you focus on the Northeast, each of those orange icons that represent basically an increase in number of heat wave days, starting from the top left corner, that's heat wave frequency, duration, the season, and also the intensity. So basically there has been an upward trend in not just the frequency, but also the duration. So overall, it's fair to say that summers could have, we have seen summers become a little bit more uncomfortable, to say the very least. So one of the common misconceptions about climate change is that, if the climate is warming, then we don't have to worry about extreme cold anymore. This cannot be further from the truth. I mean, this past winter, if you've asked someone from, the central part of the U.S., like from Texas, from up to Minnesota, you ask them, how was your winter? They would say it's very cold. And they did have a very extreme cold spell in the month of February. And, when you see places like Houston, falling into the teens, I mean, that's very unusual. But it is one of the commonly accepted hallmarks of climate change. Climate change indicates a tendency for more extremes. So in the summer, you're going to have more extreme heat waves. And in winter, you're going to also have, besides mild episodes, you would also have tendency for episodes of extreme cold. And so, but overall, if you look at the big picture, the unusually warm days, the 95th percentile, are becoming more common, but unusually cold days, which we define as the 5th percentile, are becoming less common across New England. And you can see on the left, that's 90 days hotter than 95th percentile. You can see an upward trend, as indicated by the arrow. And on the right-hand side, those are the number of days colder than 5th percentile. There's a downward trend. So, you're going to have more extremes, but more extremes in terms of unusual warmth than unusual cold. So these are other ways of visualizing the phenomenon of unusually warm days exceeding unusually cold days. You can see on the left-hand side that above the dotted line, that's number of record high temperatures, and below the dotted line is the number of daily record low temperatures. So you still get record low temperatures in winter, and they will still be uncomfortable, but the number of record highs, especially in the warmer months, are going to outstrip the record lows in the colder months. And then on the right-hand side, again, that's just another way of visualizing the same data, but you can see overall, if you draw the normal line, there has been an uptick in the daily record high temperatures, whereas at the bottom image, there's been a trend towards lower number of record cold temperatures. And so I looked at did some research and found some papers that are more applicable to southern New England, and this one is a paper on Rhode Island. And basically, in a nutshell, the number of days per year with extreme heat in the state of Rhode Island has been on the increase, and especially when you're talking about temperatures exceeding 90 degrees Fahrenheit. And so overall, the number of warm days have increased over the years in Rhode Island, but the number of extreme hot days have also been on the increase. So not only you have warmer than average temperatures, but you also have more extreme heat. And this increase in frequency of extreme heat in Rhode Island has been correlated with the the number of heat-related emergency room visits, and this is not surprising because they are, with more extreme heat, you're going to get more cases of heat illnesses, and then that will be reflected in the number of emergency room visits. And if you look at the, if you're not a fan of extreme heat and heat waves, if you look at the right-hand side image, the projected number of future heat-related ER visits are going to increase even more, especially by the end of the century. And what you're seeing here, so RCP 4.5 and 8.5, so those are different climate scenarios. So 4.5 is assuming, if we are able to keep control of the greenhouse gas emission, which is a key driver of climate change and global warming. But 8.5 is, if the countries, the governments don't do anything about it, and there's been, it's just business as usual, and the amount of greenhouse gas keeps increasing, then you're gonna have basically out of control number of future heat-related ER visits. So hopefully we are able to get the greenhouse gas emissions under control. And another way to visualize the climate change is so look at how there's been consistently earlier snowmelt related stream flow timing for the rivers across the Northeast. If you compare 1960 to 2014. So unsurprisingly, if you have warmer air temperature in the Northeast, then the snowpack, especially for the mountains in the north, White Mountains, Green Mountains, into Maine, those snowpacks going to melt earlier, and that's why this could be used as a proxy to look at climate change in the Northeast. And just one more way of looking at the climate change in the Northeast. So take a look at how, basically the warmer colors represent the last spring freeze and the first fall freeze. So basically, you're going to have earlier last freeze in spring and also later freeze in the fall. So and unsurprisingly, for the higher greenhouse gas emission scenario, you're going to have more extreme cases. In this case, again, the last spring freeze is going to occur earlier, and the first fall freeze is going to occur later in the season. So at this point, I'm going to pass it back to Joe.
All right. Thanks, Rodney. We'll grab a question. I just wanted to see if I could go back. I guess not. It looked like in the lower scenario, it was the difference was about 1 to 2 weeks and almost 3 weeks on the higher emission scenario, Rodney. So that's pretty interesting. Looking at the latest the first freeze in the fall. So it could be displaced by as much as 1 to 3 weeks. So interesting. Good stuff. All right. So let's go on to some questions, and then we'll hit up the weather briefing here. So Rodney and Bill, first of all, thanks for putting all this together. This was a great presentation. Let's see, just a comment from John. John saying the 15 and 30-year normals are now both shown on the NOAA Climate Normals page. So there you go. If you look at the 15-year, they are available. All right, question from Gary. How do you know the weather yardstick, in other words, the climate normal, for the current time frame is the same as it was for the last 30, 60, etc. years? Seems that with the advancement of technology, things like satellites, real-time ocean buoys, that the yardstick of today is different than from years ago. Any, Bill, maybe that was more on your section. Any comment on that?
Um, I'm trying to, if I think I know what you're getting at. So like if you're talking about like the weather yardstick being like the instrumentation and whatnot that they used in the past, I know when they're calculating like the normals and that kind of stuff, or specifically looking like towards like climate change and all that, they're definitely like taking that into consideration when you're looking at climate change. But when it comes to like calculating the normals, even though we've got all these advancement in technology, satellites, real-time buoys, and ocean buoys, and all those different things, anything that they're doing to calculate the normals is with stuff on the ground, or I guess with the buoys. To my knowledge, I don't believe they're using satellite data or anything like that to calculate the normals. It's all what's being observed by instrumentation, not by like a satellite now. And that's not to say in the future they won't try to incorporate that kind of stuff, but it's a little trickier because you want to get what's on the ground or in the ocean and compare it to the past, because you've got a longer period of record with that kind of data. If that's kind of what you were asking, Gary, I think that's what you were alluding to, but that's what I got.
Okay. Yeah, I think it sounded like it was more instrumentation, Bill. So, yeah, I mean, we don't have, mercury thermometers like there were 60, 70 years ago. It's different equipment, but everything's kind of measured, calibrated to the same standard. So there's obviously going to be some differences, but I think that kind of gets taken out in some of the noise in the data. So, but Gary, if that's not what we were talking about, go ahead and throw a comment in there and let us know. From Tom, and this is about weather radio, Bill. So why have we stopped providing temperature departures from the daily mean? I didn't know we stopped doing that. Is that true?
I did not know either. I'm going to
Well,
try to take a look into it right now.
yeah, it should be reporting that high, low, mean, and the departure. So
Yeah, it should be. I'd have to look into it. And I'm not in the office right
okay,
now,
well,
but
we'll look into that, Tom. And if there is something wrong, Bill will fix it. So he's also our weather radio guy. All right. From John, has the nature of precipitation changed in southern New England? For example, more long duration soaking rain versus pop up storms. Any comment on that, guys?
Yeah, I'm going to take a stab at this. So if you look at the, thanks for the question, by the way, and it differs from season to season. Like in summer, I mean, pop-up storms like today, if you get, because they are so scattered in nature, so it really depends on where you put the rain gauge, um, and in this case, our climate sites are located at fixed locations. So that's actually a tougher question to answer. But I can tell you from more of like widespread rain. If you look at the graphics for fall, so there's been an increase in precipitation for southern New England in the fall, and again, and these are theories, and part of the reason may be because there's been an increase in tropical systems, and not just that, but also the amount of rain they bring to our region, and so while we are able to present to you the average amount of rainfall or precipitation, it doesn't quite go into what kind of precipitation they might be. And likewise, in winter, you get if you talk about like last Christmas, we actually had a rain event and thunderstorms, and those by nature they produce more precipitation. So, I think so. I think the short answer is that it's tough to say exactly, is it because of stratiform rainfall, or is it because of convective rainfall? But if we do a little bit more digging, we can find out more details.
All right. And Rodney, this one's probably for you too, and it's a good question from John. Has the behavior of the teleconnections changed over the past 30 years? So in other words, it changes, in our global circulations. Have we seen changes in that?
Yeah, that's a great question. So the short answer is that the teleconnections have always played a role in our climate. And, that's applicable 100 years ago as well. But in recent years, especially in the last 20 years, there have been certainly a trend towards, and we were just to talk about the teleconnections that most people know about, like ENSO, which are El Nino and La Nina. So El Nino is the warmer phase of ENSO, and La Nina is the cooler phase of ENSO. And if we were to just look at El Nino and La Nina, those correlate with the ocean temperature anomaly of South America. And it is fair to say that the sea surface temperature has increased throughout the world, especially over the last 20 years. And so when you have, above normal sea surface temperature, you're going to increase the possibility of stronger teleconnections, which in turn lead to a stronger feedback for global climate, including the climate in southern New England. So hopefully that answers the question.
So the short answer is yes. Thanks, Rodney. That's a good explanation. From Jonathan, seems that we also have to depend more upon polar vortex disruptions to import extreme winter weather into the continental mid-latitudes. And I would say yes. If you've followed a lot of our winter storm reviews, you always see a little piece of that jet stream dropping down from Canada. That's that piece of what we call the polar vortex, and that's certainly what happened in Texas this past winter. And for us, didn't last too long, but we got in these little shots. They're called transient shots of cold, where they come in, they come out. The exception, if we go back to early 2015 here, when we had the really sustained cold and snow, that was certainly a more persistent disruption. But yeah, Jonathan, that's absolutely right. We get these, quick transient shots of cold just from pieces of what we call the polar vortex. So there you go. From Tom, has the Boston metro area thunderstorm number increased with all of the warnings? So in other words, have we seen more thunderstorm days in the Boston metro area? Rodney or Bill, I'll let you take that one.
That's a tricky one, Joe.
Yeah.
I'd have to take a look into it.
Yeah, I would say, just with the new normals here in 1991, probably we've seen a few more, but they're so hit and miss. It's tough to say, Tom. We'd have to probably look into that a little more to see what the actual trends are. But, I wouldn't be surprised if there were, honestly, because more warming, more energy, more instability. But yeah, that's a tricky one. We'll have to look into that, Tom, for you. All right. Let's see. From Mike, this is a good question here. Is there any evidence that increased urbanization in New England has played a role in higher 30-year temperature trends in terms of heat islands and loss of forest land? What do you think, Bill?
I'm sure that urbanization does play a role in the increase in temperature trends. But like when it comes to the new normals, I mean, it's really all it is we're lopping off the 1980 to 1990, 1981 to 1990 period, and then replacing it with the last 10 years. So I mean, I know, things have changed in that time frame, but you're really only lopping off a really, a smaller period of record, like when you're calculating these new normals. So I don't think when it comes to these new normals, it's a really big difference. But when I know when they're talking like longer term climate change and those kind of things, I know that's something that they try to take into account when they're calculating that stuff.
Yeah, there's probably a small signal in there, I would think. The one thing that you Rodney had mentioned before was the increase in snowfall, and the important thing to remember is now we're including the 2010s in these normals. So I know my friend Jonathan there, who's a winter fan too. We had a lot of blizzards, and the winter of 2014, 2015, the record winter in there. Those are now included. So that's obviously driving our snowfall average up, I think, from a very active, few winters there. So I think
And
that's one reason we've seen the increase in snow totals. Uh,
yeah, well, then Joe, I think weren't the '80s pretty inactive snowfall wise?
yeah, the late 80s in particular were pretty warm and less active. Yeah, you have a storm here and there, but definitely the 2010s and even part of the 2000s were pretty active. We had a number of pretty memorable storms in there. So, but definitely the 2010s I think helped bump up those snow totals, the averages a little bit. And actually, Catherine here has a similar question, talking about the warning. She's in North Central Mass, and was interested in the comment that we've seen more of an increase in the fall averages. So, can we comment on the trends across the regions in southern New England? I think, Catherine, one area there, like northern Worcester County, that's an area that's seen more urbanization the past 10, 20 years. So that could be part of the answer there in the warming. But Bill, Rodney, I don't know if you have any other ideas.
No, Joe, that you probably the nails on the head there. And then the other thing, the other thing that could be, I don't have a good feel for it, but it also could be a factor that if we've got um, better period of record in there or data in there, which is why it's really showing up, is maybe we have observers in that location, whereas in the past, when they're kind of stitching stuff together to so you can get a map of this, you maybe didn't have observers in some locations.
Yeah, and certainly the automated airport stations, those have been in place since like the mid to late 1990s.
Yeah.
So we have a more thorough record, and those were included before, but certainly, there's more of those sites in southern New England, so we have more reliable, I think, data, as you said there, Bill. So yeah, good point. Okay, so with that, let me see. Oh, we got a couple more. Let me see. One more. Um, from Linda. This is an interesting. Now this gets a little bit probably out of what our knowledge base, but she wants to know, how do we know it's greenhouse gases causing the warming trend, not something like nuclear radiation, especially considering oceans? Um, I'll just off the bat, Linda, that's probably a little beyond our scope, but the research we've seen from NOAA, which is kind of what we follow, is tied a lot of this warming to the greenhouse gases as the primary. Rodney or Bill, I don't know if you have anything on top of that.
Yeah, I think Joe, you said it. You put it very well. This is a little beyond our scope, but I would say this, Linda. Before I joined the weather service, I was a climatologist for the U.S. Navy, and we get this question a lot about what is climate change and what is some of the causes behind climate change, and I would say this, with this theory about greenhouse gas emission and the relationship with climate change or global warming, some people may put it, is, while it is not 100% certainty that they are, but it is, it is highly likely that the increase in greenhouse gas emission is related to climate change, and it has been supported by extensive scientific research. But then again, there's always there's always room for uncertainty or interpretation. But I would say it's a fair statement that these two are linked strongly linked together. So, and that it is based off on this assumption that when I did the slide on climate change, because I had to make this assumption, otherwise it would be very hard for me to give the presentation. So hopefully this makes sense.
All right, sounds good, Rodney. Yeah, sorry, that's a little bit out of our wheelhouse, but that's, we kind of rely on the information from NOAA and the National Centers for Environmental Information. So that's the answer we're hearing from them. All right, let's. If you have any other questions, if you think I'm throw them in the chat, we'll come back here at the end. I want to get into the weather briefing here to wrap up our evening. Just kind of take a look at what's going on the next few days. Definitely looking at a pattern change here. So let's start off. I'm going to go starting off with my situational awareness table, which I kind of like to use. This is a kind of a big picture look at several of the different weather parameters that we look at, and this is starting today and going out through next week. So right off the bat, what kind of stands out to me are temperature and moisture are kind of high. And actually, what I'm going to do is actually go to percentiles. I think that shows up a little bit better. There we go. So if we look at these percentiles, things like this is the height, essentially 500 millibar height, our steering flow. When these numbers, when you have high heights, you usually have high temperatures, and the temperatures, these are all max, really high with our 90 plus degree heat. The U component's pretty strong too. That's an east-west wind. Not, I guess it really doesn't apply as much in the summer as does the winter, but combination, we've got some hot weather, and look at the moisture too. It's kind of off the charts. So, no wonder we had some showers and storms here today and just, more humid weather. But notice how things kind of drop off here as we go into Thursday, especially, and even Friday. The percentiles really drop off below 90th eventually and getting down to more average. And then kind of holding that way, it looks like into next week, average. Typically at this time frame, there's so much spread or difference in the models that you don't see any big numbers jumping out at you. But at least looks like definite trend toward cooler weather, a little drier weather, maybe more average weather into next week. So now let's take a look. Let's go into our Gfs loop here and see what's going on. So let me loop this, and hopefully it shows up for everybody on the webinar too. Here we go. So I'm going to slow it down just a little bit so we can kind of see what's going on. So I'm going to let this run through, and looks like definitely we're losing the heat by the middle of the month here. Looks like more of a ridge building out west, and a few, these are called short waves, little troughs moving through. Those are usually associated with some showers or storms. So I see a number of those coming through, but pretty much flat flows. So here's our big ridge now. That eventually what we call breaks down. You see by Friday, Saturday, we're in more of a northwest flow. The big ridge of heat goes out to the desert southwest, and we're in this northwest flow. So this is more seasonable air. Even a cutoff flow there, maybe some showers and storms from that. A couple of rounds of showers and storms with each of these waves moving through. And the thing you'll notice as we get toward the end, it kind of flattens out and the flow goes more east to west. So I'll stop it here at the end. So here's our Fantasyland forecast, June 24th. And the flow, this is about 18,000 feet. It's our steering flow. You can see it's pretty much west to east. So that's more seasonable weather. Maybe, a little bit cooler, but our big, heat, if anything, is down here off the southeast coast. So everything's going to get suppressed here. We're going to lose the heat. And I think, my guess is we'll go back to a typical summer pattern, a few warm days, maybe, average kind of day, and then some showers and storms every few days. So definitely looks like we're going to lose the heat and humidity here by Thursday and into the weekend. So if you don't like the heat, there you go. Some good news for you. Let's go just take a look at the fronts here too. So this is tonight. I'm going to just loop through. We've got our little, that's a little trough wind shift line moving through with our showers and storms. And notice our cold front still up to the north through tomorrow. So it looks like another round of showers and storms. Cold front comes down from northern New England. Looks like tomorrow evening, tomorrow night, and by Thursday morning here, it's south of us. So I see nice high pressure here up in Canada. Looks like a nice cooler northeast wind. I think that will be pretty much welcome. We can turn off our air conditioners for a few days. And then as we go into the weekend, still, pretty dry. Maybe a chance of some showers here. No, not really. That low looks like it's kind of heading off the coast to our south. And then high pressure is kind of over us. Another cold front looks to come through Monday to Tuesday. So maybe some showers early next week, but certainly looks like the heat's kind of going away. And behind that, another nice Canadian high pressure. So maybe some nice seasonable weather for the middle of the month here. And let's just go take a look quickly at our 6 to 10 day. Looks like we're actually going to go odds favoring below average temperature and near or above average precipitation. That carries us to about June 19th, and the outlook beyond that. This carries us to June 22nd, is favoring below average temps here in the east, above average out west, and kind of roll the dice there on precipitation near or maybe even slightly above normal. So again, doesn't look like any prolonged heat coming up. Really, probably nothing even really, no 90s, I don't think, in that kind of pattern. Maybe some 70s, 80s, and a few showers and storms. And then our week 3-4 outlook, and surprise, Bill and Rodney, it's above normal. I think that every time I show this outlook, it's above normal, no matter what. So this will carry us to the first part of July. So looking above average weather, much of the country, a little below. It's kind of a pretty good signal there in the Gulf Coast. So maybe something tropical going on. We'll have to take a look at that. Above average precipitation. So the tropics will be heating up at that point. We're getting going, so we'll see about that. But otherwise, I think, that guy will kind of do it for tonight. And let me just remind you guys as I present this, please, send us your feedback, and I'd love to hear from you. If you have any topic ideas too, we're always taking those, always working on some new things. Let me just check for some last minute questions. Let's see. Oh, something from Gary. Let's see. Not related to today's session. We'll answer it anyway. Was Memorial Day's lovely weather, yes, the result of a nor'easter? Was that a nor'easter in May? Rodney, Bill, I think it was a coastal storm, right? We had northeast flow. Was that? Yeah, there was a low off to our south, I believe, and high pressure to our north. Am I correct?
I think that's right, Joe.
Yeah. Okay. So yeah, Gary, it was a nice late season nor'easter. So, we definitely needed the rain. That was good. It's a shame it happened over the holiday weekend, but yeah, there was low pressure kind of scooted out just to our south. And at the same time, we had high pressure to our north. So you get that northeast flow between the two, and clouds, drizzle, rain, all that good stuff. So there you go. All right. And thanks to John and Jonathan saying enjoying the webinar. That's great. Always good to see you guys. And Gary as well. And it's funny, we have a lot of frequent flyers on here. I recognizing a lot of names, which is great. So when we do the meet the staff, feel free to join those. Put your webcam on, and we can say hello to you too. We always like to say hi back. So with that,